Check. Mike. 1, 2. Yo. You're watching lesson 4.3 for Algebra 2. Welcome. Thank you. Good afternoon, good morning, good evening, whatever time you're watching this. We're graphing again. We've graphed lines. We've graphed parabolas. I think we graphed cube root functions too, I think. Did we? No, we might not have graphed cube root functions. Or cube functions, not cube root functions. We've just done some graphing in here, right? Is my point. We've graphed some things. Well, we're graphing something else. We're graphing square roots and cube roots today, okay? And it's going to feel very familiar. Do you remember this whole thing? You remember this for parabolas? And we would say, oh, it's stretch or shrink, and it's flipped, and it's left, right, or up, down. You remember all that? Right? I hope you do. We spent a decent amount of time on it. Well, guess what? All of that stuff is also true for square roots. Okay? So the A value right here tells you whether you're going to flip or not, and whether it's a stretch or shrink. Okay? And this H value is the horizontal movement. It tells you whether you're going left or right. And this K value, it's telling you whether you're going up or down. When do we go left? Whenever we see plus the number, right? Whenever we see a plus, we go right. Or we go left, sorry. I wrote that in the wrong spot. Whenever we see a plus, we go left. It's always the opposite. You remember that? The thing in the parentheses is always the opposite. You remember us saying that? Well, the thing under the square root is the opposite. And whenever you see a minus, you're going to the right. But that number plus k, when you see a minus, you're going down, right? And when you see a plus, you're going up. That is what we're used to. So let's just rattle off the transformation in words, okay? Describe the transformation. Well, when I look at this, a plus 4 means left 4 because it's the opposite. Plus, you kind of have this natural tendency to want to think to the right. It's the opposite under the square root. It's left 4 and up 7. Plus 7 we can trust. That negative out in front of the 2, remember, if it's positive, it opens upwards. It's negative, all of a sudden it flips downwards. So it's reflected downwards. And that 2, when you multiply things by 2, you're making it bigger, or in other words, you're stretching out the graph. And then that minus 1, it's under the square root, so it's the opposite of what we remember, of what we think. It's going right 1. No flip on this guy because it's a positive, but it's still a 3, so we are stretching. And that minus 5 is not under the square root. That's a vertical shift. It's telling us to go down 5. Feel free to plug it into Desmos to double check at any point if you're questioning what you think might happen. But just remember, one more time, or just to recap, that number out in front, stretch, shrink, flip. The number under the root, left or right. The number outside of the root, up or down. So, our square root functions, and we kind of saw this in class. I had a couple examples in class, actually, for 5.1, or not 5.1, but 4.2. I was thinking about geometry. In 4.2, where I had these root functions where it's just this like hump like this, right? So this is a square root function. This is what a square root function looks like, okay? And there was an example up here as well, right? So, because square root functions don't really progress very quickly, right? If you think about it, right? When you take the square root of 9, it's only at 3. When you take the square root of 25, it only goes up 5. It's not really growing very rapidly because the square root takes us down so quickly. So, anyways, what is our domain and range? Again, domain is the x values, range is the y values. So, our starting x value is at -4. So we're at -4 and then everything bigger, right? And what is our range? It's, well, starting at -3 and then it grows up from there. So everything bigger. From -3 all the way up to infinity. Again, domain is our x values, range is our y values. So when I look at this and I say, all right, the first x value is at 2, and then it just goes on getting bigger. So 2 to infinity. And when I look at my y values, the first y value is at 5, and it started opening downwards, so it's getting smaller. We always go from small to big, so actually my negative infinity will come first all the way up until, and we stop at 5. Hopefully domain and range there is simply a review, and I don't really need to spend too much time analyzing that. If you have a question, though, right, come class time, you feel free to ask me that question. So let's do like 2 graphs, right? I don't want this video to be super long and I just do example after example after example, okay? So let's just do 2 of these graphs. Let's do D and A, okay? So I don't want us to be too stressed about the stretching and the shrinking and like making the graph exact. I want us to just have a general vibe for the right thing, okay? So I look at this and I see left 2. So left 2. So there's the starting point, okay? And then the graph is just going to open upwards because it's positive and it's not stretch or shrink. So it's just a simple hump like so. Don't overthink the hump. I don't want us to stress like, did I draw it right? Just please start at the right spot by going left 2 and then do a halfway decent hump. Looking at this one, what do I got here? Left 6, up 4. So there's the starting point, right? These give you directions on where to start, and this gives you directions on how to grow. It's been flipped, so it's not gonna open upwards because it's been reflected downwards, and it's not your simple hump. We want to exaggerate it a little bit because it's been stretched. So we're gonna look something like maybe that, right? It's gonna go a little bit steeper because of the stretch, just a little bit. Nothing crazy, right? Nothing crazy, but I want you to just know and realize just about where it should look like. I suppose I could toss in one more, right? How about this guy right here? Down 5, boom. There's the starting point. Why is it down 5? Because that number's outside of the radical, so we can trust it. Minus means down. And then it's been reflected, so it's not opening upwards, it's opening downwards. Something like that. Pretty easy. And obviously, Desmos is your friend. So, when you look at this function, it's asking us to write the equation. So it's already been graphed, but we want to come up with the equation, right? Let's fill in the blanks. Is there a stretch or shrink? Did it move left or right? Did it move up or down? Let's fill in all those blanks. So let's have a look. Where is it starting? It went left 1, 2, 3, 4, and down 1, 2, 3, 4, 5. So if it went left 4, then under the radical should be a plus 4. And if it went down 5, then there should be a minus 5. And I know it's maybe a little hard to tell the stretch or shrink. Just trust the fact that, that doesn't look like it's growing very rapidly, right? There's no stretch or shrink, but we should take note of whether it's been reflected or not. This thing's opening upwards, so we'll stick with the positive, okay? You don't need to actually write the positive. I'm just stressing the fact that there's no negative, okay? So there's our function. That is this guy. Perfect. Let's do that again. Where did it start? Right 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9, right 2. So if I went right 2, that means minus 2 should be under the root because it's the opposite. And then minus 9 on the outside of the root. And it opened upwards, so it's positive, no negative. It didn't get flipped. There we are. That's it for square roots. If I went too quickly, don't be afraid to rewind, right? That only took 11 minutes. That's not gonna suck up too much of your time to go back and rewatch 4 or 5 minutes of it. I'm just trying to make this short, sweet, to the point. So, guess what? A cube root function has the exact same qualities, right? If it's negative, it's flipped, and that controls the stretch or shrink. And the h controls the left or right, and the k controls their up or down. Don't overcomplicate it. We're going to do the exact same thing with the cube root function. But take a look at the cube root function and look at how different it is. It's got a similar shape this way, but it actually goes this direction as well. Why is it that this function has a starting point, but this one goes on infinitely? The answer? You can take the cube root of negative numbers. The cube root of negative 8 is negative 2. But the square root of negative 8 doesn't exist, right? Case closed. So I have a clear starting point here because I can't take the square root of certain numbers. But cube roots, there's no limitation. You can take the cube root of any number you like. And that is why it's infinite. So, describe our transformation. Well, it was flipped, it was shrank, and that's it. No movement left, right, up, or down. What happened on this guy? That 2 is bigger than 1, so we stretched. That minus 1 means, right 1. And that plus 4 means up 4. No number out in front on C, so no stretch, no shrink, no flip. So, okay, I believe that. And then plus 10, it's the opposite. It's under the root, so it's the opposite. Left 10. Plug him in. Plug him into Desmos. What are we moving? If there's no starting point, what are we moving left, right, up, down? We're moving the middle point. That is the part that's transforming left, right, up, down, and then from there we'll change the growth, right? Those curves that split off of it will go up, down, whatever they need to do. So that is what we're moving left, right, up, and down, that central point. And then the growth happens from there, okay? So with that in mind, before I talk domain and range, let's just jump right into a graph since I was just describing that. When you look at this here, what is it telling us to do? Well, that central point is being moved left 3 down 2. So right there. And then the function spurts out from there. It's stretched a bit. So let's make the hump a little bit bigger. Like so. And then a little bit bigger downwards, like so. Not bad. I prefer to do it all at once, though. I feel like the drawings look better when I do that. Yeah, I feel like that looks better, don't you? So I think my keyboard is buzzing. What the heck? So there's that. And then let's take a look at this guy. It's been moved left 6, up 4. So left 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, right there, right? That's the central point, and then from there, things are going to sprout outwards. So, we've been reflected. So usually it goes like this, but we've been reflected, so it's going to go like this, okay? Not only that, it's been stretched, so my humps are a little bigger than usual. So how about something like that, right? I'm just now realizing that it was asking domain and range and the graph. I skipped these two thinking they just asked for domain and range. They both ask you to graph and state the domain and range. So let's just go ahead and now state the domain and range on these two. What do we got here? If this thing goes forever to the left and forever to the right, every x value is going to get touched. All real numbers, right? Or you can write negative infinity to infinity. Every number is going to get touched. Same for this one too, right? Spoiler alert, a cube root function will always have all real domain, right? Because of its natural ability to go on forever. There is no limitation left or right. And guess what? It's gonna forever grow up, right? It's slow to grow. This is not flattening out. Don't mistake my bad drawing for flattening out, okay? It's still growing, okay? It's still going up, right? Ever so slightly. It does look relatively flat, but don't get it mistaken, right? The cube root of 81 is bigger than the cube root of 50, right? It's still going to grow as you get out there on the extremities, right? The cube root of 1,000,000 is definitely going to be bigger than the cube root of, say, 1,000, all right? So it's definitely going to grow upwards as well. So all reals, all reals. And then last but not least, let's come up with our own function. Again, where our eyes are focused on that central point to determine the left, right, up, down. So we're writing the equation. We've already been given the graph. So again, we fill in the gaps with the info that we want, with the info that we need. So we have a cube root function on our hands. This is a cube root. And it's been moved left 1, 2, 3, 4, 5, and down 1, 2, 3, 4. So left 5, down 4. So the cube root of x plus 5 for left 5 and minus 4 for down 4. No stretch or shrink, because that looks relatively not steep to me, right? No stretch or shrink there. However, Well, no, it didn't get flipped either. For a second, I thought it did, but it didn't, right? It's growing, right? It's the fact that it's getting bigger from left to right, right? It's getting bigger. I'm exaggerating, but it's getting bigger. And if you look back at this one, it's going downwards for my flip. Okay, it's going downwards because of my flip. All right. So no flip on this guy. There's our final answer. What did this guy do? Left one, up 1, 2, 3, 4, 5, 6. Left one, up 6. So what do we have here? The cube root of x plus 1 for left 1 and plus 6 for up 6. And we did it. With that being said, record time, a 20-minute video. Thank you for watching. I don't want to keep you here any longer. I appreciate you. Have a good rest of your day. Ta-ta for now. I'll see you.